Hi everyone, I'm Julia Hyder, Senior Editor with Modern Machine Shop, and I'm your moderator for today's webinar, which is sponsored by Phillips Corporation. Today's presentation will cover the transformative impact of integrating 3D printing technologies into CNC machining operations, including benefits such as accelerating prototype production, expanding service offerings, and facilitating more intricate designs. Additionally, the webinar will cover how 3D printing overcomes traditional manufacturing constraints, empowering designers and engineers to realize complex geometries and designs easily. Our presenters are Jesse Cranfill, Applications Engineer, and Nathan Samson, Senior Strategic Application Engineer at Phillips. Since joining Phillips Corporation in 2015, Jesse has been instrumental in advancing additive manufacturing from prototyping to complex end-use applications. At the helm of the Additive Applications team, he focuses on educating customers and unlocking innovative solutions that challenge traditional manufacturing constraints. Nathan has been implementing 3D printing into manufacturing for the past 7 years with experience in the automotive, power generation, and aviation industries. You can submit questions for our presenters at any time during the presentation using the Q&A tab on the right, and we'll answer as many as we can at the end. I also wanted to let everyone know that this webinar is being recorded and attendees will receive a link to the recording via email. So with all of that, let's get started.
Hey, so I'm Jesse Cranfill, as introduced. We'll talk a little bit about the machine shops, as well as a little bit about what Markforged and 3D printing is. So Markforged provides additive technology with the digital forge. So that kind of encompasses our printers, our materials, as well as our software. And our primary systems are composite and metal, comprised of fused filament fabrication. So melting and extracting plastic into tool paths to create a part. So we do have polymer composites and metal. You see here on the screen a couple of our products here. Starting from the left-hand side, we have our FX20, the new released FX10, which is a composite as well, our Industrial X7 series and the Desktop series. So we have a wide range of technologies that can fit your needs in your business. Some of the topics we'll talk about today obviously are going to be relative to the machine shop, contract manufacturing, as well as hopefully brings you some ideas for how you can use additive in your shop and adopt the technology. Pretty commonly, when we think of 3D printing, we think of prototyping. A lot of companies see a great use for prototyping. We're able to quickly print and scale our prototype designs with additive in a way that doesn't require us to do machining and cause waste. So you can see some intricate designs here that we have on the screen. These are all prototypes that are validated and tested. But I will say Markforged is much stronger past just that prototyping phase, just because our materials are robust and strong. And some of these prototypes can end up being in-use products at the end.
Yeah, so something to add here as well, right? Additive 3D printing is not necessarily a replacement for CNC machining or other traditional processes. It's a very complementary technology. So these pieces you see here in front of you could be proof of concept before you go the traditional route. There can still be some massive savings in taking the the efforts of doing a traditional one-off process, where with 3D printing it's very easy.
Absolutely, Nate. Along with that, talk about a little bit of the time and money saved with 3D printing over some of the traditional methods. One is it's pretty straightforward. It's pressing, print, forging our parts. I know with a lot of traditional manufacturing, you have to have like pretty experienced workforce between designing the models, CAD, CAM, doing tool paths and stuff like that. With additive manufacturing, we're able to use any CAD program with our software. We convert to an STL, and once we've configured our part, we just hit print, and the printer goes to work for us. Another great benefit about that is the fact that you don't have to stand on top of the machine. There is no there's no like reorienting the part to machine in a different face or anything like that. We can do all that lights out, unattended. So, I mean, commonly running parts over the weekend at night. And we're obviously not subtracting any material away. So you can use the exact correct amount of material that you need to use for your application without a ton of waste.
Yeah, it's a great, especially when people start getting into additive and starting to learn how it works. It can be mesmerizing just watching the printer go. It's really exciting to see how the part's being built. But once you get that, newness kind of out of your system, right, it's fantastic. A lot of new folks really enjoy the fact that they clock out for the night, clock out for the weekend, and they come back in to build plate full of parts. That's pretty satisfying.
Yeah. Another thing I'll kind of add too is the fact that, with this being unattended and minimizing the waste and stuff like that, you come in and you clear it off, you put them right into production use. And it's kind of like another employee at that aspect. You can keep your machines doing the more important complex design and high value parts. Here we've got a couple real world examples and case studies. A lot of these are what we see in our machine shops. We talked a little bit in the very beginning about the Markforged platform. So our composites are very strong. One thing that we do a little bit differently is to give us a wide range of applications is we have our base material, and then we're able to continuously reinforce with a variety of different fibers, from carbon fiber, fiberglass, Kevlar, and a high strength, high temperature fiberglass. That allows us to meet these end use cases such as like soft jaws. The material is very chemical resistant. It's non-marring. And in the case of carbon fiber, often replacing machined aluminum parts. Most people that handle the parts are definitely going to be pleasantly surprised at the strength of these parts. From the soft jaws to the fixturing, I mean, they can handle a load. They're very, very robust. And then in the case of metals, we can handle complex geometries that are kind of inherent to the design just with additive.
Yeah, so definitely good to, again, when you're first starting out with additive, the simple applications like soft jaws, it's a low-hanging fruit. It's a great place to start, great place to understand the technology, learn where, how it works, where it fits. Some folks, when they get into additive, maybe go down the path of, well, this is kind of our holy grail part. This is, if we could 3D print our end product, everything would be changed. There's a chance that could happen, but typically you need to, adopt additive and not just, one individual. It's the business. So everyone needs to learn how it works, how to continue to solve problems and grow from those kind of low-hanging fruit of soft jaws, tooling, fixturing, up to replacing, your traditionally machined parts. So it's a bit of a journey. And to help you on that journey, everything that Markforged offers in the digital forge, software in particular with the slicing software Eiger, that enables you to bring all your users together, collaborate, keep a history on a library of parts, and helps drive wide scale adoption. Quick example here, the part in the bottom left corner is a customer part. It's for our Stanley Black & Decker. As you look at this part, it may look a bit funky, maybe not the traditional casting or machined part. That's because it was produced with additive, right? 3D printing. It's built layer by layer. So thinking about that a bit differently, and maybe holes don't need to be round, and you may not need to produce multiple parts, bolt them together. You may be able to get the job done with one individual product, one individual piece. So we've got a great details on this case study on our website if you'd like to check out a little bit of design for additive manufacturing. And also included with all of our printers is Markforged University, which is a fantastic tool to help you adopt and learn how to take advantage of the technology, where to implement it, how to design the parts, all that good stuff.
Awesome. I've added in another example here for our real world examples. This is an example from Dixon Valve. So we can see with the onyx material in this fixture that it's got a good robust jaw structure. It's got contact points that are picking up this part. And the traditional manufacturing, was 144 hours from from design to toolpath and manufacturing this part, $290. With Markforged Additive, we were able to design the part, place it in the slicing software for it. We immediately get the time and cost for material in the software. It gives you all the information before you even hit print. So once this part was printed, put into use, it was 9 hours and cost about $9 in material.
Yeah, and that's typically you see those savings. It's very impactful, and these are just kind of the immediately seen benefits, right? Time and money. As you continue to grow and adopt, you'll see business transformation happen, and impact goes greater than that.
All right, we've got a short video here I'd like to show you with one of our customer testimonials here, and let you take a look at.
I started racing as a kid, actually, before I could drive legally. I had a motorcycle, and having the need to go faster and quicker drove me to start developing some of my own parts. Other racers I've come encounter with over the course of racing for a season would want to buy some of our stuff. So that's basically how I got involved in the business. As things progressed, we found the need to get into CNC machining. We bought our first Haas machine from Phillips, and they were great to work with and very supportive, still are today. The machine's never been down a day in its life since I've had it. I started looking at the printing technology, taking into account the manpower shortage specifically and the supply chain issues we were coming into, because in racing business it's all about now. And if you can't get the material you need to make the parts when you need them, it doesn't matter what kind of parts you make. I contacted Phillips again. They had partnered with Markforged, which was 3D printing technology, and arranged a meeting over there. When it was all said and done, we basically bought the machine that day.
After talking with Wyatt, what we're able to do is kind of show them with Additive, they can take a part they've designed, place it into the software. They can immediately see the print time and cost. Once it's in the software and set up, they're able to send it to the printer and print it pretty much hands off. Kind of like a whole other employer. It runs night and day. They can do a lot of things remotely just from the software. It's kind of the great thing about the Markforged side is that the device's material and the software is all connected.
Any issues I've ever had, I've been able to immediately reach out to Phillips and get extremely fast and prompt support. We've even had Jesse, the main additive engineer here at Colfax Phillips Corp, come out on his own volition and help us. And I think just stuff like that really speaks volumes of both their belief in their product and their willingness to help their customers. In drag racing, one of the biggest concerns for everybody when they're making parts is the weight. By being able to print parts instead of machining them out of aluminum, we can shave as much as pounds off of something.
On average, we're saving about 63% of the cost of what it would typically take to produce the same part out of aluminum. I mean, what would take us weeks to sit down and design a machine, we could do that in a matter of hours, and there's absolutely no waste involved in it. I mean, it's really, really been a game changer for us.
So Hawaii is a great example of using their additive complementary to their actual traditional manufacturing in-house. And just because they're using the printers, they're able to keep those CNC machines running, more important things, more efficient things to keep their business running while the printer is still busy at work. So Nate, I'll let you talk a little bit more about exploring new market opportunities with 3D printing.
Yeah. Right. An example relating to that video we just saw. You have a CNC machine, say a fairly small business. that could be a huge bottleneck of getting everything through, maybe one or a couple CNC machines. And your machining tooling, it's a huge weight off of your CNC equipment to use the printer to produce that tooling. There is a chance that the 3D printer could just replace the part you're machining altogether, but more likely there's a chance that your end product has maybe more specific material requirements, and we can just support that process, that traditional process. I think that's one of the big takeaways, especially as you're getting into printing, is it's very much a supporting process. So allowing as you bring in 3D printing, right, it's going to enable you to do more, right? Say yes to more of your customer requests. Not our machine shop may be too busy. We don't have the head count. A 3D printer can absolutely help solve some of those situations where you have to say no, or you may have to farm things out. And as we'll get into a bit later, we've got some good examples, right? Geometries that are not possible with machining. So as all you're probably very well aware, every manufacturing has its limitations. 3D printing does as well, but they're different. So there may be scenarios where someone comes to you with an idea, and maybe it's too complicated. Maybe there's a lot of specialty tooling that's required to produce that piece, and 3D printing may be the easy button for that. There's a chance that as you load that into the slicer, right, the machine doesn't care about with texturing. That could be time consuming. It could be complex curvatures, right? All those are a piece of cake for a 3D printer.
Absolutely. So something else that you're able to do with Additive is you can certainly break into new markets. I mean, with your low volume, high mix production and stuff like that, oftentimes, the cost is kind of passed down to your customers from the tooling cost and setup and everything like that. But we can break into new markets with Additive as well. I mean, Additive is out there in a lot of different industries. Industries are kind of seeking that out. So that's another aspect of where you can touch in new markets. Freeing up your machine availability from your CNC shops, we've kind of hit on that a few times, is running that machine to do more product, producing more things, while allowing the printer to do those things that are more tedious, or maybe you're having to use a machine specifically to make your fixturing, or using your workforce to make fixtures, welding and sheet metal bending and stuff like that, just to make something to be able to produce your parts. That is something that you can reduce your time with a 3D printer. There's definitely a wide range of applications that are enabled with our materials with Markforged, just because these composite parts are reinforced continuously with those fibers that I mentioned earlier. The base materials that we have for the composite side range from just a base material onyx, but we also have like a flame retardant, self-extinguishing version, an electrostatic dissipative version of that base material, along with a smooth TPU. And we have a material available for precise PLA is basically what is oftentimes used for prototyping and proof of concept. So that's kind of a great thing like that. When it comes to metals, we're able to do 17-4 stainless, A2, D2, and H13 tool steels, which is pretty common. Inconel 625 and pure copper. So I will kind of touch base on that, is like some of those materials can be difficult to machine. So why not let the printer do those applications for you?
Yeah, and especially on the metal side, again, different type of manufacturing process, different limitations. Complexity comes free, and that's really beneficial with metal printing. There's a really great kind of analogy between our metal printing and casting, where most folks aren't looking for casting to be the fully, right out of, once that casting is finished, it typically needs some additional machining, right? You true up critical surfaces and don't on non-critical surfaces. With metal 3D printing, it can be very similar. So it's a great way to get your part, say 90% of the way there. Use your composite machine for holding that custom unique geometry, and do the precision machining only where it's necessary. So let's see, diversifying. So this is really big. Kind of something you can relate it to, right? Diversifying your investments. Like if you're wise with your investments, you're not going all in on one thing. That can be kind of translated to manufacturing environments where you have CNC equipment, and diversifying your capabilities with additive can be huge. You can also kind of diversify what you offer to your customers. Right. The market for additively produced parts is growing. So the actual end product from the 3D printer, it enables you to do, again, say yes more to your customers, that low volume custom parts, where the traditional process, your customer comes to you and says, hey, I need 5 of these. And you look at it, everything that's required to produce, you get it priced up, and it's like, well, we probably can't, offer a reasonable price on this unless we produce 1,000 of them. So it allows you to get into that low volume, custom market. And again, it's another tool in the tool belt to just satisfy your customers' needs. So again, the goal of saying yes to more and more of your customers.
Absolutely, Nate. Yeah. And I mean, the capability that you can bring in-house isn't just necessarily just reaching out for specifically additive, like offering that just as contract manufacturing, but because of the wide range of things that additive can resolve and bring in-house, I mean, you can essentially bring things in-house that you've never done before as far as your applications and things that you've done. So that's a very interesting way to use additive. I do have another video here for us, another testimonial.
My name is Jeff Stroop. I'm the tool and die shop manager for D&M Holding. I've been connected with Haas and Phillips now for 33 years. Whenever D&M decided to start setting up an actual brick and mortar building, they contacted me to build the shop. So we had nothing in the building, it was an empty building. We started out from scratch. Well, the biggest challenge was to try to figure out what all parts we needed and what pieces of equipment we needed to make a variety of parts without getting equipment that wasn't going to be running. When we started setting our shop up, Hunter and Carrie came by, introduced us to the printers, brought a sample printer over, and we printed a couple parts, looked at it, and thought it was a great fit for what we were doing.
My name is Hunter Kubitz, and I'm a Markforged sales specialist for Phillips Corporation. Mostly he was looking for just fixturing and work holdings for his CNC machines, as well as prototyping. The parts that Jeff was looking at ended up working perfect for the Markforged technology.
So on the first parts we printed were some waterfalls for one of our packaging machines. We identified that as our first part because of the amount of machine work that was needed done and the cost between the material and machine time. When we started printing them, we found out that the payoff on the machine basically was within the first 30 to 45 days. With the printer, we do a lot of prototyping. We'll print up a part to test out our theory and design, and then we also print a lot of use parts for feed tube adapters and different products that we actually put on some of our equipment.
For the most part, he does most of his applications with just the Onyx base material, which is a nylon 6 with micro bits of chopped carbon fiber inside of it. Then he also has the capability with this printer to also reinforce the parts with full strands of reinforcement material, such as carbon fiber.
Markforged printer has exceeded our expectations for several reasons. Your product, cost, your print time. The biggest thing with Phillips is the professionalism. Your support, your sales, everything is very professional.
was another great testimonial from Jeff over there at D&M Holding. They've done a lot with that printer in a very short amount of time, reaching out to new applications. And each time that we've gone in there, they've found more applications to add to their technology there with Markforged. Yeah, go ahead, Nate.
Fantastic to see folks really adopting and realizing the potential of what the new technology can bring them. You've got ideas, you've got new products, you've got things that you may want to try to see if it improves your workflow. With a 3D printer, you no longer have to go through the long, strenuous process of producing that one-off part, that idea. You could say, hey, that's a great idea. Let's send that to the printer, and potentially the next overnight, your new design is ready to go to try out. That could be a huge improvement in your workflow. Having that part in hand next morning, there's a potential that, hey, that wasn't a great idea, but you've learned very quickly with minimal effort, and you're on to the next thing. So it really enables you to be efficient with process improvement ideas and bringing ideas to life, get a touching feeling, then putting them into the real world application goes a long way. All right, chat about constraints with 3D printing. So we kind of talked earlier about how every manufacturing process has restrictions, limitations, capabilities. Right, it's nothing new. Machining, casting, injection molding, EDM, they're all good at certain things. So transitioning how a 3D printer can be complementary in a machining type environment. Think about how you traditionally go about setting up a machine. There's programming. You have to worry about accessing features. Do you have the right tools to reach in where you need to? There's a good chance there may be multiple setups. A lot of times, folks that are designing the parts don't necessarily understand how the parts are being made. So that drawing gets sent down to the machine shop, and the machinist immediately turns it away and says, yeah, not a chance. Hit the drawing board again. This is going to take way too much time and energy to produce this part. And hey, maybe this is something that you don't have the ability to do, and you have to outsource it. So now you're relying on someone else's equipment, facility, their timeline. Outsourcing is definitely never the fastest way to get something done, and quality's not under your control either, so it can be difficult going that route as well. So yeah, 3D printing is a new tool to add to the tool belt, and it can be complementary to your current offerings. And it's not the end all be all of everything will be 3D printed going forward. It'll be bits and pieces of a lot of things can be.
So we've touched on this a couple of times too, is the design complexity and customization. Nate said it best earlier, design complexity comes free with a 3D printer. The fact that, when we think about the traditional machining route of things, there's multi-axis, multi-part setups and stuff like that. These are things that, within the build volume of the printer, we can combine those geometries into a single print. We're able to print that pretty much all in one go. So, I mean, if there's knurling, if there's labeling, dovetail joints or anything like that, some type of joinery that you want to incorporate, all those things can kind of be done on the Additive platform right from the beginning. Like it's designed, it prints. We can also do a lot of unmachinable internal geometries, right? Because we're building up layer over layer. So we're able to reach a lot further into our parts than what you would be able to machine. And in some cases, it may not even be possible to manufacture a different way. I've got a photo. The photo here in this picture is a project that we've worked on before in the past, but this is essentially an air knife or something that would clean up from to reduce downtime inside of a machine. So this part originally was sent to us as 2 pieces. It needed to be able to build up pressure, and the tool is basically supposed to go into this pocket get blown off and go back in. So a design improvement that we're able to do and print all in one go is we have teardrop channels that run from the airline throughout this kind of horseshoe here that was able to fix the machine and greatly reduce their downtime. They didn't have to fab this. They didn't have to make this in multiple part assemblies or anything like that. And the tool works great. So it's in use as of now. Yeah.
Yeah. Great example of how, a lot of times cookie cutter parts or generic parts. I'm sure there's things on the market like this that are just generic, and they may work okay, but the ability to see something and say, hey, that would work a lot better if we change the inner diameter, if we get it a little closer to the tool, or we add, maybe we need more air holes. This was a very quick way to produce a better tool than exists on the market. And yeah, thinking about how you would produce this outside of 3D printing, having to potentially drill all of those holes, all those pockets, and then going back in and maybe plugging them on the backside to create all that internal geometry. If you really wanted to get crazy, you could get some like CFD on this and get a really efficient airflow going where, hey, that channel doesn't need to be the same diameter all the way through. Maybe it needs to start out larger and start to get smaller as it reaches the exit point. So yeah, possibilities are endless of how you could really customize it and dial in, say, a product like this.
Here's a couple more examples of showcasing some complex geometries that we've enabled with 3D printing.
Yeah, so this tool cooler here on the right, a company called PTZ, kind of similar to what we just chatted about. There's internal cooling channels that are spiraling down this piece on the inside of this piece. This was something that they were trying to produce traditionally, machining in aluminum. Copper is obviously has much better thermal properties, but copper can be tricky to work with through subtractive. So the fact that our printer doesn't care whether it's a hard tool steel or a very soft copper, it's able to make that geometry and create those conformal internal channels. So this was a productivity piece here for machine shop as well. That part in the bottom center there, that is a fixturing tool, multi-part, fairly large, and the complex design. So you have a bent tubing that's laid in there, and that's an inspection fixture. So you can see, hey, has this part been bent to spec? Does it sit well in here? Easy way to get some measurements on it. So a conformal tool like this, again, for traditional processes would be quite difficult, quite time consuming and expensive, where with a 3D printer, it's very easy to produce. Again, these complex geometries, complex is relative, right? Certain technologies can do things easy, and they can be a challenge otherwise. So complex parts with additive may just look a bit different. For example, that teardropping shape Jesse mentioned earlier, you're able to produce self-supporting geometries. This is getting a little bit more into the weeds, but with support material that's required for overhangs with a 3D print, if you were to print a round hole, like in that previous example, the air knife, that would require supports, and then you'd have supports on the inside of your part. But because we're not using drill bits to produce those holes don't necessarily need to be round. So those internal cavities can be designed to be self-supporting. And a common way to do that is the teardrop shape. So you take your traditional round, hole that's been drilled and just add a roof to it, peak the roof a bit. So as you're printing, all the layers are coming together at a 45-degree angle and do not require supports. That doesn't need to be teardrop. That could be a diamond shape. It could kind of be like a house shaped where you've got a rectangular cross section with a peaked roof on it as well. It all depends on how what geometry satisfies the need. And again, that type of talk track and how to solve your issues and solve them with additive, that talk track can be learned in Markforged University. It can definitely help you, kind of think outside the box a bit of, hey, this part looks like this when I cast it. It looks like this when I machine it. And it's going to look a little different when I 3D print it. But each one of those designs could still, accomplish the task at hand.
Yep. All right. It looks like this is the last of our slides, but we obviously want to just kind of reiterate with something that Nate just said. I'm kind of here on complex geometries as far as like the Phillips support side. We talked a lot about the Markforged University. That's something that's available like kind of throughout the companies with with our digital forge. But as with Phillips, we're able to support helping with the adoption, helping with the education of things. So we do have additive application engineers. We obviously have our regional sales as well as our service field technicians. So Phillips is ready to support and answer questions. So I just want to touch a little bit on the services that we offer with that.
All right. Thank you, Jesse and Nathan. It looks like we're starting to get some questions, but there's still time to submit one. You can do that using the Q&A tab on the right, and we'll do our best to get to it. But if we don't get to it today, someone can follow up with you via email. So our first question, this is kind of a two-part question. So part one is, are there any materials you can't do? Titanium, super, duplex, stainless. Those are just a couple that they mentioned.
Yep. Yeah. See the question here. So great question, right? What are our material capabilities? So we get this question very often. A lot of folks have applications where they traditionally use, say, aluminum, and aluminum isn't a great material to bring to our 3D printing platform. Sintering can be a bit complex. So what we tend to do is dive a bit deeper. Why are you using aluminum? And a lot of times the answer is, well, it's what we've always used. It's easy to machine. That's how we're producing the part. And you throw an interesting question out there of, well, what if the part can perform, similarly strength-wise to aluminum? Would you be okay with that? And many times the answer is yes. So our 17.4 stainless steel can outperform aluminum in strength. Our continuous carbon fiber with Onyx can outperform aluminum in strength. So if the reason you're going for a specific material is, kind of like, well, this is the way we always do it, think outside the box a bit. There may be other options that we can provide for you. However, there are definitely situations where a very specific material, a very specific alloy is used, and for very good reason. So there definitely are applications like that. This is where we tend to recommend 3D printing as a supporting process for that very specific alloyed part. So we can help you get that specific, say your titanium part. We can help you produce that titanium part traditionally a little more efficiently with 3D printing work holding fixtures or inspection, holding, things like that. So generally speaking, we recommend taking a look. We did cover a lot of information today, but we did mention the majority of the materials that we offer. If that wasn't something that you could see using, we recommend taking a deeper look into your applications and thinking, hey, are any of these other materials capable of performing the same task?
Okay, and the second part of that question is, how long does it take to change over from one material to another?
Yeah, go for it, Jesse.
Yeah, I was going to say for both composites or metal, when changing a material, realistically, all we have to do is kind of wait for the nozzles to heat up. So, I mean, we can do a pretty easy change out within 5 minutes or so with the anywhere from on the metal side from 17.4, we can switch over to copper. The system does have like brushes to kind of reduce any type of contamination between. Composites very similar. We're wait for the nozzle to heat up. We take our spool out, place a new spool in after we've weighed it, and we're ready to run again.
Yeah, and because our technology is FFF or FDM style printing, right? It's all filament based. There's no loose powders, so it's incredibly easy to handle the material. There's no heavy facility requirements for handling the material or operating the printer. However, on our first slide about who is Markforged, we did mention, or in parentheses there was metal binder jet. That is a very different technology, very different scale. Just for quick understanding, that technology is great for producing tens of thousands, hundreds of thousands of small intricate parts, mass production, 3D printing. I'm assuming that that's not the audience that we have today, so we definitely focused more on our FFF composite and metal offerings, supporting small, medium-ish type machine shops. But if that is something that interests you, high volume, mass production 3D printed metal parts, definitely check out our website, learn more, and reach out there.
Awesome. We have another question here. What tolerance ranges does copper yield looking to accelerate sinker EDM tooling for prototypes?
Yeah, so we definitely get this question a lot. There is no real easy, direct answer. Very much depends on how well the part is designed for the technology. If you're trying to do a part that, say, size-wise, is pushing the limits of the size that we can do, you may see a bit worse dimensional accuracy. If you're trying to do features that are right in the sweet spot, overall X, Y, Z size, as well as what your individual features look like, right? The way our extrusion paths are laid down. Say, for example, we can't produce single micron, tens of microns level, features. So that's definitely something that would still need to be precision machined. Generally speaking, you can say like plus or minus 0.5%. If you're looking in like the 0 to 60 millimeter range, and maybe plus or minus 1% for parts larger than that. So again, one of the easiest ways to consider or to think about how the metal geometries come out, casting is very similar.
I'll just add, essentially coming out near net shape for those parts and everything like that. So Nate kind of touched on it just briefly just now. As far as designing for, pretty familiar with designing for the process that we're using and taking it in the design for additive concepts, either with working with a application engineer from our team or utilizing Markforged University can greatly increase the success of things like that.
Yeah, and especially sinker EDM tooling, if you are looking for, polished finish, very precise features, a copper 3D print could get you, again, 90% of the way there. And it could make it very, copper isn't the easiest thing to machine. So if all you have to do are finishing passes, that could be a huge benefit. Again, not replacing, the machining, but it's helping to support and aid the manufacturing process, right? Complementary technology.
All right. Another question here. I'm interested in 3D printing components for injection molds. Several years ago, we did some testing and found the inserts cracked in the water lines under injection pressure. Material was stainless steel. Do you know if this is still an issue, or would it be worth it for us to investigate again?
It very much probably depends on what type of technology you were utilizing. Was it the Markforged Metal X to produce those stainless parts? There's many other types of metal additive. But I guess a general statement, technology is changing rapidly. Talking about the digital forge and software being a huge pillar of that, we are constantly rolling out updates to our platform that bring on new, the ability to do more and more applications. So if it's been, several years, I'd strongly suggest looking into that again, because there's a chance that it may be possible now.
Okay. Oh, he clarifies it was before the Metal X came out. So.
Okay.
Yeah.
The Metal X was very unique for its time. When it came out, there really wasn't any other metal technology like that. So it's a very different approach of producing parts. So it helps to unlock more applications than the other metal applications that are metal printing technologies that are out there. Each have their sweet spot. Ours being ease of use, low barrier of entry from a knowledge and cost perspective, and the ability to do those low volume, custom parts. One day you could be printing 17.4, the next day you could be doing copper, the day after that you could be doing Inconel. Super easy to just send something completely different to it, every day.
Okay, I have one more question here. So if you are still looking to get something in, I would encourage you to do that right now. But for now, the last question is, I'm interested in learning more. Who do I contact? And can I talk to someone about my specific use case?
Yeah, absolutely. So you can reach out to us. We've got a Markforged at phillipscorp.com, where we can connect with you, help you with your validation, help you through adoption, talking about bringing this in. And we had the question talking about the Metal X and process and stuff like that. Something where you can send that to our Markforged at phillipscorp.com. We'll get it to the right people or our team to reach back out to you to discuss that. We can also share more information when it comes to specifics. Markforged has done a great job of providing information from the strength of the materials, more information on the composites, as well as design guides and stuff like that for their product.
And this is, application engineers like Jesse and myself, this is what we do well. And I know I can speak for myself. This is what I really enjoy doing. Learning new customers, manufacturing processes, seeing, some of the difficulties that you may run into, and then helping adopt additive to make things more efficient. That's what we do well. So definitely, if you think there's a fit, you want to chat with a specialist, reach out. We can start diving in.
All right. I think that's all for today. I want to thank Jesse, Nathan, and Phillips Corporation for making this webinar possible. And thank you to everybody for listening in. You should receive an email with a link to the recording soon. Thank you for your time and enjoy the rest of your day.
Thanks, everyone.
Thank you.